All right, let's get started. So before we get started, I'd like to take a moment to thank our sponsors for making this event possible. We really appreciate their support in bringing the PowerShell community together. Um, First, a little background about myself. I'm a software engineer at Microsoft. I'm part of the Azure Deployments team based in Redmond, Washington. I'm one of the contributors to several other deployment features, including the deployment what if, and more recently, Bicep and Bicep extensibility. And outside work, I do a lot of hiking, camping, and during winter, I go snowboarding every weekend at Stevens Pass and Crystal Mountain in the Washington state. So here's what we'll cover within the session today. First, we'll go over the background, why deployment what if exists, and what problems it solves. Then we'll dive into the internals, how it actually works behind the scenes, what happens when you run what if, and how it determines what will change. After that, we'll look at the limitations and what's next, some of the challenges we're tackling, and the features we're actively working on to make what if better. And finally, I'll show a live demo so you can see it all in action. So let's start by looking at why we need deployment what if. Deployments in Azure can be risky sometimes. You might accidentally override production tags, change a SKU without realizing it, or deploy the wrong template entirely. These kinds of mistakes can lead to downtime, unexpected costs, or just a lot of confusion. What we really need or want is a way to predict the impact of our deployment before it happens, to catch potential problems early and avoid surprises. Now, before we dive into Azure deployment what if, let's look at something you are already familiar with, PowerShell's what if prep. It's very simple but incredibly powerful. For example, if I run remove item with a path and with the what if parameter, PowerShell won't actually execute the command to delete the file, but instead it will give me a notice about the operation you will perform. Notice that nothing is changed here. It's a safe simulation. This concept of previewing changes before applying them is exactly what we wanted to bring to Azure deployments. Now, introducing deployment what if. We've seen the challenges and the PowerShell inspiration, and we want to apply the same concept to Azure deployments. Deployment what if basically lets you predict the changes your deployment would make before you actually run it. It will show you adds, deletes, and modifications across your resources and the changes for your properties as well. Essentially, it will run a diff between the desired and the current states. It works with both ARM templates and Bicep files. And by the way, also ported to Azure CLI. So once you run the deployment what if command, it will render the output, which is designed to be clear and easy to interpret. On the right-hand side, you can see a screenshot from a sample deployment what if output. We use meaningful symbols to indicate the change types. Those symbols and certain parts of the text are highlighted with colors. Those colors are wisely chosen to have high contrast for better accessibility. We've tested them on both white and black backgrounds, as well as the classic PowerShell bluish. Excuse me. As well as the classic PowerShell blue background. The properties are well indented to improve readability. The change types of deployment what if can be categorized at two levels: the resource level and the property level. At resource level, we have create, delete, which only applies if you do a quote unquote complete mode deployment, and modify, which indicates that the resource will be changed. No change is for a no op deployment, and ignore is kind of special. It's for resources that are not part of your ARM template or Bicep file, but they exist in the same resource group. Unsupported is useful in cases where what if cannot evaluate certain runtime properties of a resource, so it cannot tell you about the changes. The deploy change is only used when you tell what if to run a diff with resource ID only mode. So it basically won't tell you about the property changes. All it tells you is that I'm going to deploy this resource. At property level, we have create, delete, modify. In addition to those three change types, we have array, which is used for a property that is an array, which can have nested changes. And no effect is used for properties that don't affect the that will cause no change. Usually, this is annotated on properties that are read-only or immutable, meaning they cannot be changed by the user, and their value is usually generated by the resource provider service. So understanding these types can help you interpret the diff output more effectively. So now that we know the basics of deployment what if, let's take a look at what happens behind the scenes. When you run deployment what if, um, first it will send a request to the server side, specifically to the Azure Resource Manager service. So the deployment engine within ARM will evaluate your template without applying any changes. So it won't send real put requests to the resource providers. It then treats your deployment request as the evaluated deployment request as the desired state, and then pulls the current state of resources by making individual GET requests to the Azure Resource Provider APIs. Then it compares the desired state and the current state to detect differences. Here, some pre-processing process is needed to ensure the diff is clean, which I'll talk about shortly. So this pre-processing is actually the core part of what if. And finally, once what if has the diff, it will return the user the result, which will then be rendered by the Azure PowerShell or Azure CLI client, giving you a clear preview of the deployment outcome. So next, let's dive into the core part of deployment what if, which is the pre-processing process. So the pre-processing process is driven by a metadata system that we built from the Azure OpenAPI spec or Azure Swagger definitions, which is an open source project, by the way. So you can go ahead and check out the definitions yourself. So what the metadata tells what if include the property attribute. For example, whether a property has a default value or if the property is read-only or not. Similarly, there are write-only properties. So what if can use those metadata to inject default values to the desired state before running the diff algorithm. You also use the metadata to remove read-only properties from both the desired and the current states. Some examples of read-only properties include timestamps generated by the resource provider services. Those cannot be set by the user. Additionally, he will sanitize the write-only properties or secrets to avoid secret exposure. So the secret values on the desired state side, or which is defined by the user, their values are replaced with a placeholder. So the same placeholder is added to the current state as well to ensure the diff is clean. So in addition to the static annotations that we get from the Swagger definitions, the metadata system also allows us to do some more advanced special handling for things like conditional defaults, because there are certain resource types within Azure. They do special things to like, for example, a certain property has a different default value based on a value of another property. And similarly, there are also conditional read-only and conditional write-only properties. So what if needs to understand all of this to make sure that the diff is accurate. Some other examples of pre-processing include normalization of property values, uh, such as the top-level location property. When you specify the location property, it can be all lowercase without white spaces, or it can be a full name that include spaces. So what if needs to normalize them before running the diff? Because otherwise, you even with the same name, same location with different format, you will see a change. And we also do normalizations for IP CIDR format and so on. There's another special handling that we do, which is for tags. So tags is kind of special in Azure because it is widely used um, on resources such as VMs and so on. So when you define tags through ARM template or Bicep files, sometimes you don't want the tags to be replaced, but instead you want them to patch on top of the existing tags. So a lot of resource types choose to adopt the patch semantics instead of put. So what if we'll need to understand this to make sure that we generate clean diff for the tags property. There are other more advanced pre-processing that what it performs, such as the give out access policy changes simulation. So yeah, next I'm going to show you an example on what if diff pre-processing. And for this example, I'm going to use the Microsoft.automation/automation accounts/variables type resource type. So this resource type is kind of special because it has a conditional default. So when you create the variable, you will need to specify a value, and optionally you can specify the is encrypted property to indicate whether the value needs to be encrypted or not. If it's true, then the value is a secret. So actually, I mentioned conditional defaults, but it's actually conditional write-only. So by default, the is encrypted property is false. So let's assume that I have already created a variable with a default is encrypted false value, and the value is current var. And now I want to modify the chain, the variable through a Bicep file or ARM template file. So I set the value to a new value, and then I invoke what if. So when what if receives the request, it first checks the resource type, and in this case, it finds out that it's an automation account variable. So it loads the metadata for this resource type, and realize that the is encrypted property has a default value false. So I'm going to inject that into the desired state. And now we have the desired state, and what if will trigger a GET request to get the current state of the resource type. So with the current state, there's no read-only property, there's nothing in the metadata. So what if we'll just use it as is? And then what if we'll do a diff to compare the two states? And finally, we'll get the result and successfully detect the change on the resource, on the value property. Now let's assume that I have created the variable with encrypted set to true. And this time, when what if get the current state, it will only get the property is encrypted true, because the value in this case is a secret. So the RP won't return it in the GET response. But on the desired state side, since it's declared by the user, the value will be present, will be presented there. But now, since what if understands that the value is a secret when it's encrypted is true, um, based on the information in the metadata, what if will replace the explicit value of the value property with the secret placeholder, and it will inject the same value into the current state before running the diff. And the end result will be no diff for this value property. So in this case, what if won't actually tell you about what changes will be applied to the value because it's a secret. But this is a by design behavior to ensure the output is secure. Yeah, that's basically about the core part of what if, which is the diff pre-processing process. So while what if is powerful, it's not perfect yet. We have to admit that. There are two main problems today. First, sometimes the Azure structure definitions for resource types are inaccurate because they are defined by the resource provider teams, which you don't have control over. This sometimes can lead to unexpected results or output. Specifically, they can produce false positive results, which are often referred to as noise. Those are changes that appear in the diff but don't actually happen. For example, if a resource provider forgot to annotate a property as read-only, what if will show that property in the result as a deletion because it exists in the current state, but it's missing from the desired state. Another problem is that since ARM template can contain expressions and sometimes runtime expressions, those expressions cannot be evaluated when what if processes them because their values are only known if you actually deploy the template or send the request to the resource provider. So if that happens, sometimes what if will fail to evaluate nested templates, and as a result, the prediction is less precise because resources inside unevaluated nested templates may not be returned in the what if result. So the diff is actually incomplete in those cases. So looking ahead, here's what we are currently working on to address those limitations. One key improvement is auto noise filtering or auto noise suppression using deployment stacks. So with deployment stacks, if you run what if for a stack, what we do is that we will record the false positive results and sort of do a diff for the noise or a diff of diff. So that we can automatically filter out some of the noises. And another area that we're improving is nested template expansion. So we've been making some changes to our template evaluation engine to make sure that nested deployments are expanded even with unevaluated runtime properties. So if you want to learn more about these fixes, there are some other great track 4 sessions which happened earlier today at the conference. Those are covered by my colleagues from my team. So yeah, please feel free to check them out. And finally, there are some links about our projects. So first one is the Bicep GitHub repo. So Bicep is owned by our team and it's our top priority. So if you haven't heard of Bicep, just feel free to check it out. And also there's a Bicep community call that happens every month. So here's a link to sign up for the community call. And during the community call, we'll share updates about Bicep deployment stacks, deployment what if, basically everything our team owns. And yeah, to complete my presentation today, let me just show you a demo so you can see what if in action. Um, so first, let me make sure that can everyone see my VS Code window? Okay, nice. All right, let me go back to VS Code. So here on my screen, as you can see, I'm showing you a very simple Bicep file. For those of you who haven't heard of Bicep, it's just a DSL that we build on top of ARM template to simplify the authoring experience and to uh, enhance compile time validation. So within this Bicep file, for demoing purpose, I only have one resource, which is a storage account. I have several parameters, including the storage account name, the location, and the skill name. For the skill name type, I'm using the resource input utility type that Bicep provides to get access to basically access the skill name type, which is a union. This is convenient because I don't have to specify the union type myself. I don't have to remember all the values, all the member types of the union. If I hover over the name here, you can see that it tells me what the type is. And one nice thing about this is that if I let me delete this default value for now. If I trigger validation, it will provide a list of available items I can use as the default value of the parameter. So if you specify the parameter in the Bicep param file, you will get the same completion experience. So yeah, then for the storage account, nothing special. I just use the parameters to populate all the properties. And there is also like a enable large file shares property, which is a Boolean, and I use it to set the large file share state with a ternary operator. So now to demo what if, let me open my console. And let me zoom in a little bit so you can see the command. So notice that I have a new Azure deployment, AZ resource group deployment commandlet. I specify the template file, and because I have default values set for my parameters, I don't have to specify the parameters file path. And then I give it my resource group name, and most importantly, the -what if flag. I'm going to hit run. And this will this only contains one resource, it will take about like 10, 15 seconds. But for a larger template or more complex template, it can take longer. So after I hit run, what it will we just saw like a status message telling us that what if is getting the latest state of the resources. So now the command completes, and as you can see at the top, we do have like a note or warning about the false positive result or noise. And we encourage users to report the issue. And then we just show you the symbols, which I mentioned earlier. In this case, since I haven't created the storage account yet in my resource group, I'm getting like a create change type, and it's also showing me that this storage account will be deployed under a resource group. So for all the properties, they are shown as a flattened list with indentation to help improve the readability. And notice that all the values are fully evaluated, all the parameters are replaced, and the ternary operator should also be evaluated. However, if you look at the large file shares in state, it's showing as enabled. But in my parameters file, in my Bicep file, I set the parameter to false. So that indicates that something's wrong in my template. And if you look at the ternary operator, you notice that I messed up with the values. So actually need to swap enable and disable. So I'm going to do that. Okay. Now the value is swapped. So that should fix the error. And by the way, this is actually not a recommended way to define a parameter to populate a property value with a union type like this. Uh, so I'm using a ternary operator because I want to show you guys the capability of what if. But in reality, it will be better if you can declare the large file share state parameter as a union type, just like the skill name. So now that the error is fixed, I want to deploy the template, but just to be on the safe side, I want to do run what if as well. But instead of using the dash what if flag, I'm going to use the dash confirm flag, which is also a built-in flag that PowerShell provides. But in this case, we override it, so it will invoke what if. So I'm going to hit enter, and this is telling me about what if is doing right now. Again, it's getting the latest status of the storage account. And we'll just let it run for a couple more seconds. Okay, now it completes. And if you look at the large file share state, the value is disabled, which is exactly what I want. But since this time we use the dash confirm flag, the commandlet won't wait, but instead it will prompt me to ask me if I want to execute the deployment. So I'll just do yes. Now this will trigger a real deployment to deploy the storage account. And while we're waiting, I do want to highlight that in addition to the create change type, what if also returns me the ignore change type for a different storage account that's already there in my resource group. So this resource is not defined within my template, but what if still showing it as a change. So yeah, now my template deployment completes. This means that the storage account should already exist in my resource group. Now to demo some other change types, I'm going to make some minor tweaks to my template. So I think I'm going to change the skill name to standard LRS. And I'm going to change enable large file shares from false to true. And maybe I'll add some tags. And GitHub Copilot is pretty useful here. I'll just use the value it suggests. And now, to verify my change, I'm going to trigger what if again. And we'll just let it run for a couple of seconds. Okay, now as you can see, it returns me more change types. There's create, modify, no effect, and ignore. And for create, that's annotated on our tags because the property is new. And for modify, you can see that the large file share state is changed from disabled to enabled. Similarly, for the skill name, it changed from standard GRS to LRS. But there are also a few no effects, which is annotated on the encryption.services properties. So this means that those properties, regardless of the value you specify, they will have no effect because the service will just ignore them. And actually, if you go back to my Bicep file and hover over the property, it it shows the a description of the property. We basically generate the description from the address record file provided by the resource provider. And you can see that in this case, for this specific API version, the properties cannot be disabled. So this means that you can actually safely remove them from your template.